Hi all, so welcome to the today's tutorial. So we will revise what we have covered and we will continue our quest with our vectors. So just to recall, we see like how we can calculate the magnitude and how we can get the normalized vector and the dot product. If not, I would request you to go through those videos so you will have the better understanding. So we have covered this and how to calculate each and everything inside the vectors. So today concept is the cross product. So cross product is like give me a second. So let's imagine there are two vector a and b. So a cross b will be a vector which will be the perpendicular to these two vectors. So the blue line is a, the red line is b. So the perpendicular to that line is a cross b. So if you look carefully, give me a second, let me open the paint. So here, if we have a vector this, which is going this direction, let me draw it properly. This is one vector and this is another vector. Okay, this is perfect. So the third vector, which will be perpendicular to these two, let's imagine this is x and this is y. This will be x, this is y. Let's imagine, okay? So the third vector will be z, right? So if I will do x cross y, so it will give me the up vector because so when I'm talking about x, y, z, so this will give you this vector. But the interesting thing is if we will do it opposite, if I will do y cross x, it will be the opposite vector. So in that case, it will be this vector. It will start from here only, you know. So it will be like negative z axis. You got my point? So in dot product, when we will do a dot b, in that case it was equals to b dot a. So it doesn't matter when you are, multiplying it a dot b or b dot a. These were the same because it will be equals to a b cos theta. But when we will look at the derivation of x cross y, we will see why is it happening. So a cross y, a cross b is not equals to b cross a. And when we are talking about x and y, x cross y is not equals to y cross x. So previously when we look a dot b is equals to ab cos theta. Similarly, x cross y is equals to xy sin theta. So let's head back to this particular website. This is really good just to understand the concept. So here when we are talking about a b sin theta, here we have a directional vector. It's a unit vector which is denoting n cap. Okay, so this is why the when we are talking about a cross b, it will give us a vector itself. It won't give you any scalar value or the magnitude value. Previously, when we were doing a dot b, it was giving us some magnitude, right? Okay, perfect. So A cross B, that means, and okay, so when we are doing A cross B, let's imagine if I am particularly talking about IJK, that means X, Y, and Z. So A X comma Y, X cross Y will give you Z. But if I will reverse this, so in that case, I, J, K, these were the representation of X, Y, and Z. So when I am multiplying I cross J, it will give you K, the third axis, because these are perpendicular, right? When they are perpendicular to each other, that means sine theta will become 1. Perfect, perfect. So, so this is K, and when we are reversing it, it will become minus K. Okay. Similarly, when I will do I to J, J to K, it will give you I, but K to J, it will give you minus I. Perfect. Next is K to I. K to I, K cross I will give you J, and I cross K, it will reverse, so it will give you minus J. And when you will multiply the same vector to itself, so I cross I, we know when we are talking about a vector which is in the same direction, the angle will be 0, right? So when I'm drawing a vector this and I'm again drawing a vector this, so my drawing is not that good. So okay, so let's draw these two vector and let's think they are pointing to the same direction. So in this example, the angle between these two vector is 0. Perfect. And sine theta, when we are talking about sine 0, will become equals to 0. So that means this will become 0. So that is why I cross I is equals to 0, j cross j equals to 0, and k cross k equals to 0. I hope you understand this concept, right? When we are multiplying same vectors, it will become 0. When we are multiplying, some other two vectors, it will give you the 90-degree, a vector which will be perpendicular to them. So we assume two vectors A, B, C, and X, Y, Z. Uh, when we are doing cross product, you are saying like I am multiplying AI to X, Y, Z, these three. So when we are multiplying, uh, so AI will be multiplied with Xi, Yj, and Zk. This is what we are doing here. So A, when we are multiplying with X, this one, so it will become I cross I, because vector will be multiplied with vector, and the constant we can just multiply as it is. So A and X for the constant. So AX multiply like I cross I, it will become 0, because we already know like the same vector will give you 0. And when we will multiply this with this, so it will become a y and I cross j. I cross j will give you a third vector called k, right? So we have k. Similarly, when we will multiply ai with zk, that means az, and ik is reverse of ki, right? So it will give you minus j. Similarly, we are multiplying all these three, like 3 cross 3, it will give you this. And when we will remove the 0 and we will just take the common, when we are taking common I, j, k, it will give you this solution. So this is how we can calculate the cross product. And we always use right hand cross rule. So let's imagine if your first vector is representing the first finger, and the second vector is representing the second finger, then your thumb will represent the third vector, and we will call it as I A cross B. Okay, so this was it. Now we will see how we can implement the same scenario inside our cross product function. So I will just copy paste this. Just uh, it's a cheat sheet, and I would request you to do the same. So let me close this, and below dot product. Now, when we are talking about the cross product, it will give us a vector itself. So cross product and const vector and vector const. And this one more thing, actually, we can mark everything constant. Reason being is, if we are following the tutorial, we had one issue using the R value and L value, if you remember that, right? Mm-hmm. Okay, perfect. So alt enter, generate definition, and for these alt enter. Okay, now let me put the const here. So it won't give us that error which we were getting before. And in the cross product itself, okay, I forgot to copy that. Okay, I copied it again. So we have our cheat sheet. So we will have three values which is representing xyz of a vector. So first is b and z. So b, a, b, c is like of our main vector. So b in the case y, and multiply with vector dot z. Okay, minus c is like z multiply with vector dot y. For this z multiply with vector dot x multiply vector, okay, z x minus x multiply with vector dot z, and this will be x multiply with m vector minus y multiply with m vector dot x. Let me reconfirm if everything is correct or not. Okay, it will be dot y, and it will be x. Okay, this is x z z y. Yes, z x x z x y and y x. Perfect. This is perfect. So this will give you the cross product. Now we will test it inside our game mode if we are getting the correct answer or not. So what I will do, I will have two equations, x and y, and I'm just flipping. No, I'm just flipping for x y scenario. What I'm doing, I am taking two x's, x and y. So when I will do the cross product, so some dot cross product, and inside this I will give you some vector 2, and here I will again do the cross product but with the first vector. So I'm doing a cross b and b cross a, and we will check what vector we are getting. And we don't want to normalize anything, and I don't want to print anything too at the same time. Let me play. Okay, this is up. When we are compiling, I can't see anything. Now I can. Okay, this is quite a good big vector. Oh, fuck, this is huge. But when I'm doing the cross product, okay, actually we can do one more thing. You know, after doing the cross product, let me you know, get normalized vector, so it will turn the whole vector to a unit vector, and we will just multiply it with 500. So what it will do, it will we can write like in vectors we are not multiplying it with okay, so we can override it because we can multiply with we haven't done it yet, so I will override it multiplication, and it will be a float, const float multiplier. Let's imagine we when we do want to multiply our vector with some multiplier, so in that case if we'll just multiply it with x multiply with multiplier, sorry, multiplier, comma y multiplier with multiplier, comma z multiplier with multiplier. Control D. Okay. Okay. Okay, this will be the return statement. I think, okay, now it is working. We'll do the same with the second one. Dot get normalize. I'll just put the parenthesis. So, okay, let me compile this again. Okay, now it is looking better. This is one vector because we have this head on the top, and when we are looking below, this is another vector. Okay, this is perfect. We are not drawing vector A and vector B, so we'll do that too. So some vector dot draw vector get world, and some vector 2, sorry, because of my cough I am unable to speak much, get world 2. We can compile this again. Let's see. Hmm, this is perfect. This is x-axis, this is y. This is when we are doing a cross b, it will give you the up vector, and when we are doing opposite, it is giving us the opposite vector of z vector. That means a minus z. So I hope you have clear understanding of the cross product and the dot product. They are very, very relevant for our mathematics, vector mathematics, and the game. Like in lot of the situation, you will need to have the cross product, dot product, and the application is really, really huge. So I would request you to go through it and how it is working. If not, let me know in the comments, so I will help you out. So thank you and have a nice day, and do subscribe. I do want to increase my subscriber. It is very much low. So thank you and have a nice day, and help me with Patreon. Bye bye.